In this video, we'll look at how to manually or automatically set the date and time on your Linux server. We will look at how to run programs in the background and how to kill programs that we want to stop, how to create a symbolic link, which is similar to a shortcut in Windows. Let's start out with symbolic links. A symbolic link is also called a symlink in Linux, and a symlink is simply a pointer to a file. A symlink is analogous to a shortcut in Windows, so that should be familiar. Note that you can have several symbolic links pointing to a file or to a directory. In Linux there are both soft links and hard links. Hard links are not used as much now, so we'll concentrate on soft links. An example of how to create a soft link is with the following command. ln makes this link, -s means a soft link, then we have the name of the file or the name of the directory, and then the name of the symbolic link. For example, if we wanted to create a symbolic link to the documents directory, ln-s home user, notice this is a capital document, so this is the actual name of the directory, and then we indicate the name of the symbolic link, which is lowercase documents. Let's see how those are represented in Linux. So let's go to the Suspend directory and do a long listing. And note here on this line, if we go all the way to the left, notice that there's an L here, which means it's a link, a symbolic link. We go over here to the last column, and notice in light blue it says start, and there's an arrow, and then there's a name of an executable. Start is a symbolic link, which is indicated by the arrow to the right, to the file, which is an executable, init control. Notice that there are three other symbolic links in here. There's one called status, which is a symbolic link to initial control, and stop, which is to init control. And finally, there's a symbolic link called swap off, which is a symbolic link to swap on. If I run start, status, or stop, what this does is that since it's a symbolic link to init control, it will actually run the executable init control. So you can create a symbolic link to an executable as well as a regular file, for example a text file or a Word document, or to a directory. And let's see how that's done. So let's do a long listing, and we notice that we've got, let's look at these two directories right here because everybody has them. The capital documents directory, capital downloads directory. Well, I don't like having to type the capital D here for documents, so let's create a symbolic link to that. ln-s, the name of the directory, and then the name of the link. I'll tell you what, let's just call this docs. So ln-s for soft link, the name of the directory, and then the name of the symbolic link. We hit enter. Let's do a long listing. And you notice here that we have a symbolic link called docs that is a pointer to the documents directory. Let's first cd to the documents directory and look at its contents. Notice we've got several files in here. Let's go back up in here and cd to the docs directory, do a long listing, and we're seeing the contents of the documents directory. And we access that with the symbolic link. So you can also create a symbolic link for a regular file, and then you can access the contents of that file with the symbolic link. So notice that we have a file here called hello.txt. Let's look at the contents of that. And it says hello world, hello again in the file. And so let's create a symbolic link to that, then let's access that file with a symbolic link. So the name of the file, and then the name of the symbolic link, h.txt. Let's take a look at that. Notice that h.txt is a symbolic link to hello.txt. And now, if we access h.txt, we see we have the contents of the file hello.txt. Let's change the contents. Let's add to it. Write and quit. And let's look at the contents of hello.txt now. And notice that the contents of the file has been updated. We can also access the link, which will show us the exact same information. Now let's look at how to run commands in the background. When you issue a command from the command line, it typically runs in the foreground. However, you can push your command to the background and still have it run, allowing you to gain access to the prompt. You can suspend a job. You can suspend a job by using the Ctrl+Z command. And what this does is it suspends the job and allows you to continue issuing commands from the foreground. You can restart the command by using the BG command and the job number. If you don't have any other commands running in the background, then you don't need to use the job number. Let's see how that works. So let's run the command ls-alr for long listing recursive, starting at the root directory, which will take a long time to run. And what we can do is we can hit enter, we hit Ctrl+Z, and notice that this says that job number 1 was stopped. If we type jobs, notice that it's stopped, and we can continue issuing commands here, hello world and so on. Type jobs 1. If we type background and 1, it continues running the command. So let's say that we're running a command and we realize that it's the wrong command and it's going to take a while to process, or we just have an application that's hung and isn't responsive. One of the things we can do is we can stop the processing of the job, or stop the process using something called the kill command. And so what we need to do is we need to find the PID, the processor ID number, which is a unique number that identifies each process, and to issue the command kill-9, which means to terminate the process with process ID whatever. And there's a couple of different ways you can identify the process ID, one of which is to run psaux, and the other is a command that I just came across recently, and it's called PID of. So PID of and then the long-running command name, and you need to issue the first command that you used, and it will identify all the PIDs associated with that command. And so let's go back over here and let's rerun this command. Sudo find, let's type F and execute md5 sum, and let's output that to a file 3.md5, and we'll run that in the background. Okay, now this tells us the PID right there, so we can just issue kill from right there. But if we wanted to find the PID using PID of, you can type PID of sudo, and it tells us that 19,234 was the PID of this command right here. And so we can type kill-9 19,234. Whoops, we need to issue that as sudo because we're dealing with raw memory here. And jobs, and you notice that that job was killed. You can also run commands from the background by issuing a particular command along with an ampersand to indicate to run the command in the background. So what this allows you to do is to recover your prompt so you can continue typing on the command line. So let's go over here. And let's run ls ls-alr and the root directory and the ampersand. If we type ls-alr for the root directory and the ampersand, the output still will be going to the screen. But however, the command will be running in the background. All we need to do is to create a file in our current directory or anywhere. It says file listing, and then the ampersand, and the command will run in the background, and you'll be brought back to your prompt while still running this command and creating this file. Hit enter, which brings us up to another topic. Let's pause this. So those errors provides us with a teaching moment, as I call it. Recall in an earlier video we discussed standard input and standard output. Standard input comes from your keyboard typically, and there's a numeric value associated with standard input, and that's defined as 0. That might be meaningless right now, but in a second I'll show you how you can use these numbers to your favor, especially with respect to dealing with standard error. And standard input can be changed from the keyboard to a file by using the less than sign. And in a second we'll see how we do this. Standard output is considered your monitor or your screen. And Linux defines that as number 1. And you can redirect the output from your command, as we've illustrated numerous times before, using the greater than sign. Now we need to add something called standard error. And these are errors that are thrown by a program. For example, what you just saw in the illustration previously. And typically, standard errors are thrown to standard output, which is your monitor or your screen. And Linux defines standard error by the number 2, so 0, 1, and 2. If you don't want to see those errors, if you don't want them thrown to your screen, you can redirect or ignore standard error by sending the standard error to something called the bit bucket, and this is the device called null, and essentially it acts as a trash can. It doesn't hold anything because once you throw something to dev null, it goes away. So in the previous example, we could have typed ls-alr and then the root directory, and then we would send the errors to the device dev null using 2 greater than, and there's no space in there, 2 greater than, and then dev null. Let's see how we can work with standard input, output, and error using those numbers. So first let's use standard output, and we've done this many times. So let's type ls-alr as an example and output that to a file called file listing. And so instead of sending standard output to our screen, we're sending the output to a file. And we already know how to do this. File listing, and there's our file, the contents of the file. And now if we want to send, instead of the keyboard standard input, to let's say a command, we can type cat, we can type less than, then file.listing, and you see that it works the same way. And so instead of having the input being your keyboard, is that we're sending this input, the file.listings, to the cat program. So let's go back and rerun this command, ls-alr, and for the root directory, and we want to send the output to the file listing. I can't remember what I used before, file listing, and then let's send those errors to the bit bucket. Let's hit enter, type clear, and let's see if the command ran. Let's file listing, and there's our listing. And we didn't receive those errors. You can also use dev null if you'd like to remove the contents of a file. And occasionally you'll see this used somewhere on the internet by an advanced Linux user but let's just show you how this works. So we saw that file underscore listening was quite a large file. If we cat the contents of dead null to file.listing, what this is doing is taking the bit bucket, which is essentially null, it's nothing, and sending that to the contents of file.listing. Let's go back and look at that, and now it's 0 bytes. And the contents are gone, but notice that the file name still exists. So again, these are some advanced Linux topics, but it might be something that you come across on the internet and you wonder what it is, but now at least you've seen an illustration of how standard input, standard error, and standard output work. So let's go back to our previous command before we saw those errors, and let's type a command that's going to take a while to run. So let's type sudo find type file, and we want to execute the MD5 sum. We want to hash all the files, and we left one thing off here where we want to start. We want this command to take a long time, so let's start from root, and we use our braces, and we want to output that to a file here called files.md5. And if there are any errors, we want to send that to the bit bucket greater than dev null, and we want to run this in the background. That was the whole point of this command, right? So we're going to find all files, not directories, but files under the root directory. For those files, we're going to execute a hash function. We're going to hash these files with the md5 sum command. We're going to output the results to files.md5 in the current directory. If there are any errors, we're going to send those to the bit bucket, and we will run this in the background. So we hit enter. Notice this was job 1. The PID is 1301, and so this command is running in the background. And so now let's see how we can set the date on our system. You can set your time and date in several different ways. The easiest way is to use the command ntpdate for Network Time Protocol Date. ntpdate is a client which allows you to set up your date and time to a very precise date and time by using signals from an atomic clock over an internet connection. And the command to run is ntpdate and the URL of the atomic clock. And the default atomic clock for Ubuntu systems is ntp.ubuntu.com. So let's type date at the command line, and you see it's saying that it's April 8th, Saturday at 2006, Pacific Daylight Time. And obviously this is wrong because this is being run in 2010. So what we need to do is to run sudo ntpdate and then the name of our server, hit enter, notice it gave me a warning, timestamps too far in the future, but that's not correct because that is the actual date and time. So it had downloaded the information from the atomic clock. It showed what the offset in seconds was, and we type date, and now we're up to date, Tuesday, November 9th, 7:48, 2010. And actually there's an error in here because we're not on Pacific Standard Time, we're on Eastern Standard Time. And in a second I'll show you how to set time zone information so that this hour will be set correctly to the current time zone. But before we do that, let's take a look at how to set the date manually, and that's very easy to do. And we do that using the date command. So let's hop back over here, go to the next screen. And so using the date command, we can use the, and this is wrong, thank you PowerPoint for setting this, that should be a dash dash rather than a single dash. So date dash dash set, and there's different ways of executing the date command. The standard is to put the day first, followed by the month in capital letters, the year, and then the time. So running this command, we would set the date to November 10th, 2010 at 9:34 in the morning. Let's go back over here, clear this, and run sudo date dash dash set. And now we want to set this to, let's set this to some other date, because we already know what the actual date is since we just ran ntp update. So let's say it was October 31st, 31 October 2010, and the time is 1:34 in the morning. So hours, minutes, and seconds. We hit enter. That's our password, and there's our current date and time. Run date again, and we see that it's holding the current date and time. Actually, it's better to use ntp update and to put that as a cron job, so that every hour or every day or every week that the ntp date is run, so it synchronizes the time clock on your computer with that of the atomic clock. Now let's get back to the earlier issue we were looking at, and that was the problem with the time zone. This information about setting the local time was taken from this website. So as it turns out, there's a file called localtime in the etc directory, and it's a link or a copy of a file containing information about your time zone. And we saw before we were on Pacific Standard Time. Well, we should be in Eastern Time right now. And so what we need to do is we need to update this file so that it points to the correct time zone. And it turns out that time zone information are in files in the user share zone info directory. This depends on your distribution, but with Ubuntu, zone info, and let's just do a listing here, and you'll notice that there's lots of different files as well as continents and countries. So let's do a long listing here, and notice it's a directory called America, so we can cd to America. And you see a number of different files in here for different time zones, and we want to search for one that's going to be in Eastern Time, and a good one to search for is New York, because we're in the same time zone here in Florida, at least the eastern half, and that's going to be in the Eastern Time Zone. And so what we need to do is that we need to either copy that file and replace local time with New York and rename it local time, or create a link to it. So let's type clear. Let's go back to the etc directory, and local time. You see here we've got local time. And so let's first, let's go over here and look at our notes. Let's keep a backup copy, or make a backup copy of this file. So we want to copy etc local time to etc localtime.old. Then we want to create a link from the file user share zone info America New York, and make the link etc localtime. And then we need to issue the command hardware clock, which is used to synchronize the date and time with that file. And the command for this is suspend hardware clock and sys_thoc. And if we want to see what sys_thoc stands for, let's do the right thing and use the man page. Let's search for sys_thoc, and you see sys_thoc sets the hardware clock to the current system time. So the first thing we need to do is make a copy of copy local time. And let's call it local time dot, or actually let's move the file local time to local time dot old. And now what we can do is to create a symbolic link to user share zone info and America and New York, and our link is in the current directory, which is the Etsy directory. I'm going to call that local time. And there is our link to that file. And now we can run hwclock. First, let's run date. You see it's October 31st, 2010. And before we do this, let's go ahead and run ntpdate to get the correct date. And so sudo ntpdate ntp ubuntu.com. Okay. And notice now that the date is set correctly. It's 10:57 and 54 seconds. And so now it'll be kept up to date. And if we want to see